All right, we're going to start going over the rest of the problems from the test, at least from 15 to 20. All right, on problem 15, it says in the diagram below, quadrilateral ABCD is inscribed in circle P. What is angle ABC? So always focus on the question. What is ABC? And right here we have this angle ABC. I want you to write down this note. We haven't talked about much in class. But when you're thinking about a quadrilateral inscribed in a circle, if that is the case, the opposite angles are supplementary. What does supplementary mean? Adds up to 180. So hopefully you remember that. And I'll just write up here, adds up to 180 degrees. Okay, so if you know that angles A and B are 110 and 72, that means the opposite angles would be supplementary, which means they would have to add up to 180. So if you know, if you're looking for ABC, the opposite angle would be ABC, or angle B. If that's 72, to 180 minus 72, that gives you 108. So our answer is 3. Okay, looking at number 16. It says a hemispherical tank is filled with water and has a diameter of 10 feet. If water weighs 62.4 pounds per cubic foot, what is the total weight of the water in a full tank to the nearest pound? Okay, there's a lot of stuff going on here that they don't really say in the problem that you need to understand. So when it's talking about a tank being filled, automatically you should start thinking about volume and not area. And it has a diameter of 10 feet. You have to know what a hemispherical tank is. A hemisphere is half of a sphere. They have the formulas for a sphere in the back of your test. I believe so. I'm looking right now just to make sure. And you should have a test. Yeah, they have the volume of a sphere as 4/3 pi r to the third. You have to know that a hemisphere is just half of that. So half of 4/3 is 2/3. And hopefully, we've been taking a lot of quizzes on this, and hopefully you remember that. All right, so we have everything we need now. We have our volume of a hemisphere formula, and we know the diameter, but we don't need the diameter, we need the radius. So the radius is equal to 5 feet. So we're going to plug this in to find the volume. 2/3 times pi times 5 to the third. And when you plug that all in, make sure and do to the third, because it's easy to, you know, a lot of things with a circle, at least the area, it's pi r squared, and then a cylinder, you have, you know, pi r squared h, so you have r squared. But volume of a hemisphere or a sphere is r to the third, so be careful. So when you plug all that in, you end up getting the volume is equal to 261 point. I'm just going to write down all the numbers that are in the calculator. And if I was doing this on a test, I wouldn't even take it out of my calculator. So this is what you end up getting in the calculator. I wouldn't even take it out of the calculator. And now you have to think what they're actually asking. This is how many, and again, this is actually cubic feet, or feet cubed. So that's the volume of the container. So that's how many cubic feet that this hemispherical tank can hold. But notice the other information they give, that water weighs 62.4 pounds per cubic foot. Now, if you're in my class watching this, or if you're watching this and you happen to be in my class, you know that I have a little poster that actually has an actual replica of a cubic foot. So if you were to fill that up with water, what it's saying is the water would weigh 62.4 pounds if you could fill that cubic foot that's in my room.
So, you know, different materials are going to weigh different amounts. If you pack a cubic foot with feathers, it's obviously not going to be as much as if you fill it up with water. And there are other things that would be more, that would weigh more. So water weighs 62.4 pounds per cubic foot. So if it holds
approximately this many cubic feet, all you do is multiply this by 62.4. And you end up getting to the nearest square, not square, to the nearest pound, because what we're finding now is an actual amount of pounds. This is how much it would weigh, number 1. Okay, looking at number 17, it says in the diagram below, triangle ABC is, hopefully you know what this means, similar to triangle ADE. So ABC would be this bigger one, and ADE would be this smaller one. All right, it says which measurements are justified by this similarity. Okay, a couple things. If you've been watching these videos over and over again, you might have written down something like this 3 or 4 times at this point. Not really sure, but at least another time, I'm sure. But I want you to write down these notes. It says, when triangles are similar, here are some things we know. And here are 2 important things. The corresponding angles, I should say angles, are congruent. And the corresponding sides have this same ratio. All right, so let's look at our answers. It says AD. So let's look at the first one. Is number 1 justified by this similarity? Well, it says here AD is 3, and AB, the entire thing is 6. And then AE is 4 over here, and the entire thing is 12. Well, does 3 over 6 equal 4 over 12? Well, hopefully you can see right away that that's not true, because 3 is half of 6, and 4 is definitely not half of 12. Also, you can cross multiply. If 2 fractions are equal, or 2 ratios are equal to one another, or if they have the same ratio, the cross products will be equal. And here, 6 times 4 is 24. That does not equal 36. So that's not our answer. So number 1's not. All right, let me go ahead and we'll erase this now. Erase some of this stuff. And we have, for the second one, AD is equal to 5. And AB is equal to 8. And then it says AE is equal to 7. AC is equal to 10. Okay, this is the one that could trick students, because they look at it and they say, well, 8 is 3 more than 5, and 10 is 3 more than 7. But that doesn't mean you have the same ratio. It's like saying 1 to 4 is the same as 97 to 100. Well, those are nowhere near. Even though even though 4 is 3 away from 1, and 100 is 3 away from 97, that doesn't mean that those are equal ratios. So the way you need to check it is going 8, well, 5 over 8. You could do 8 or 5 or 5 over 8. So I'm going to do 5 over 8. Is that equal to 7 over 10? Well, clearly it's not, because 56 does not equal 50. The cross products are not equal. So those are not, they do not have the same ratio. And if it was similar, if this truly is similar, then it needs to have the same ratio. So 2 is not right. Erase this again. And we have AD is 3. AB is 9. And we have AE is 5. And AC is 10. All right, again, is 3 over 9 equal to 5 over 10? Hopefully you recognize pretty quickly that those are not. And that leaves us with 4, which, well, let's just make sure, because maybe we made a mistake somewhere else. So we have AB is 2, and AB is 6. AE is 5, and this is 15. Is 2 over 6 equal to 5 over 15? Well, hopefully you realize pretty quickly that 2 is 1/3 of 6, or 2 times 3 is 6, and 5 times 3 is 15. If you do the cross products, 30 is indeed equal to 30. So there we go. Number 4 is our answer. Okay, number 18, it says triangle FGH is inscribed in circle O. The length of radius OH is 6, and FH is congruent to OG. All right, they give you some information, but they don't mark the triangle. So when they say FH is congruent to OG, that means that this side is congruent to this side. All right. Well, looking at that, well, let's read what they're actually asking us. What is the area of the sector formed by angle FOH? So angle FOH would be this one right here, and the sector would be this entire segment of the circle. All right, so I want you to write down the area of the circle, because it might be helpful to find the area of the entire circle. So let's go ahead and do that. So the area of the circle is pi times 6 squared. So the area is equal to 36 pi. All right, 36 pi. That's the area of the entire circle. So if I were to shade this entire circle in, right, the entire thing, the entire circle is 36 pi. And if I were to multiply that out, that's like approximately, I don't know, 115, around there. I don't really need to know that, but 36 pi is a value. So if I do, I'll do it in my calculator really quick. And it is 113, so I wasn't far off. But all we want to know, all we care about is this sector right here. What is the area of that? So, I don't know. Common sense would tell me that it's not 24 pi, that it's not 2 pi, and that it's not 3 over 2 pi. I mean, the only really, as I'm looking at this, the only one that makes sense is 6 pi. So I'm not sure if that's the answer, but looking through it, that looks like the only one that makes sense. So let's go ahead and do some more figuring, maybe to come up with a more concrete, some more concrete reasoning as to why it is what it is. So we know that this FH is the same as OG. We already marked that. But now you notice OF has to be the same also. Now think about that. Why is that? Well, the reason is, and hopefully you would be able to pause this and write it down yourself or know it yourself, is that these are both radii. So we have a radii here, a radius here, and we have, this isn't a radius, but they already told us that FH is congruent to OG, and OG is a radius. So that means FG is the same length as the radius. So that means we have here an equilateral triangle with all the sides being 6. All right, now, what do you remember about an equilateral triangle? All degree measures. Actually, I'm going to write it like this. All interior angles measure 60 degrees. So we know that this here is 60 degrees. So now I'm going to write some stuff here. And we have this being 60 degrees. All of them are 60 degrees. So think about this. If it's 60 degrees, and an entire circle is how much? 360, right? So that means that this triangle, the interior angle takes up, if I were to reduce this, I end up with 1/6. That means that this triangle or this angle takes up 1/6 of the circle. So this entire segment or sector takes up 1/6 of the circle. So if we have an area that is 36 pi for the entire circle, what is 1/6 of 36? Well, it's just going to be 6. And then throw on the pi. There we go. So 1/6 of 36 pi is equal to 6 pi. So the answer is 3. And that should have been something that hopefully would have been common sense, but we just went through and showed our reasoning behind it. All right, looking at number 19. It says, as shown in the diagram below, segments A, B, and CD intersect at E, and AC is parallel to BD. Given that triangle AEC is similar, remember this means similar, again, we're seeing this symbol. If you don't know what that symbol means, you're in for a lot of trouble. Given that triangle AEC is similar to triangle BED, which equation is true? Okay, what I want to do first here is write down all of the corresponding sides. So which sides are corresponding? You can tell from the lettering here. So if you look at the lettering, AE and BD are corresponding. So side AE and BE are corresponding in the two triangles. So I'm going to write corresponding sides. So AE and BE, so it's going to be AE and BE. And we have EC and ED, so EC and ED. And number 3, we have AC and BD. So AC and BD. All right, so now let's answer the question. Which equation is true? So is CE over DE equal to? Now let's go back to our last. Also, we know that similar triangles, the corresponding sides have the same ratio. We're going to be dealing with that because I don't see anything about angles really here. All right. So is CE over DE, so CE here over DE, so CE over DE, those are our corresponding sides, CE over DE, is that equal to EB? And I want to show you why this is not right, because they did this side over this side. Is that equal to this side over this side? No, that's not true. If it were flipped around, if this were flipped like this, it would be true. If the EB and EA were flipped, or if the other one were flipped, you could say that's true, but it's not because they started and said CE to the smaller one, so they went from bigger triangle to smaller one. Then they, on the other side of the equation here, they went from smaller to bigger. That's like saying 4 over 8 is equal to 2 over 1. Well, that's not true. Now 4 over 8 is equal to 1 over 2. Now that is true, but this is not true, and this first one is not true. All right? Okay, look at number 2 now. Number 2. It says AE over BE. So we have AE over BE is equal to AC, all right, over BD. Is that true? Well, that looks true. They started and said AE, big triangle, to corresponding side in the other one, BE, is equal to big triangle, AC, over its corresponding side in the other one. So that looks right. So as I'm looking at that, that looks like our answer, but let's check out the other ones. So on number 3, answer number 3, it says EC over AE is equal to BE over ED. Okay, again, this is kind of tricky on this one. So I want you to look at what happened here. I'm going to go through that again. They said AE. I'm sorry. Again, they said, so I'm looking at number 3 here. EC. So this side is to AE. All right, now remember, the corresponding side to EC is ED. So in order for this to be true, this would have to be up here, this would have to be down here. So it's tricky what they did. They said equals BE over ED. Had to be in another order. So that's not it. And then the last one says ED over EC is equal to AC over BD. Again, they did the same thing. We'll erase that again and show why. They did from small triangle to big triangle. Then in the second part of the proportion, they went from big triangle to small triangle. You have to either go big to small, or small to big, small. You can't like, so for instance, if they had switched these, they would be, all right, but not, so 2 is our answer. All right, that's all I'm going to go over for today. So hopefully you get something from this. If you have any questions, just ask me in class.